I think one of the most exciting things about object storage right now is you saw Amazon and just the wealth of applications that are getting built, but there's different use cases that are actually getting applied. And one of the most interesting, we talked about smart data. Our belief is that as you store this bulk data storage, you're able to store this capacity storage, we're able to tier it off to the cloud. Why can't I actually run analytics on that data as well? And the use case that we had was very much with a number of our different customers, but also ourselves. We had the challenge, as Mike had mentioned, on bulk amounts of data coming back into us. How can we actually do analyze in place? So we did work with Hortonworks to basically do full Hadoop validation, where all of the data, I'll just jump to it, all of the data is effectively stored in Cloudian Hyperstore. You can run basically Hadoop MapReduce directly against the database in place, so you don't move it. And the benefits, there's a couple of benefits. I mean, this was done about 3 or 4 years ago, where Amazon actually did some testing with S3, and it was built into the Hadoop ecosystem. One of the challenges they had was locality of reference. How do you actually manage that? So we actually use our data center locality and our kind of conformance stuff to actually enforce locality of the data as well. So there's a bunch of other things we've added. So the key thing here, we talk a lot about Internet of Things. I mean, capacity storage, the volume of capacity storage is going to explode from now until 2020. You're going to have 40 zettabytes. We all know the data. A lot of that is going to be this kind of stuff. Consumer activity, device tracking, social media. It's going to be these new apps that are sending in huge bulk amounts of data into your storage systems. Moving those bulk amounts of data into an analytics system is a costly thing to do. So the work we did with Hadoop was, why can't I run Hadoop analytics directly on the platform? And so what does that look like? So effectively, this is the Hortonworks kind of full summary. It's Hortonworks certified, Yarn certified, Pig. You can use Pig for transform. So as you're trying to actually go and I love the little pig picture. But as you actually want to take data and you want to do effectively an ETL on that data so that you can reorganize it better, then you can actually use it with Pig, and then you can do Yarn analysis on top of that. So there's like an 80 or 90 page kind of test document that we actually did jointly with Hortonworks. Type of stuff that's in that test document is you test effectively, HDFS looks like a Linux shell almost. So you can do all of the shell commands are tested, all the file I/O operations, including mass uploads. So oftentimes you're actually doing big bulk file uploads. We can do multi-part uploading of that and chunking of that. So we do a much more efficient kind of uploading of that. ETL with Pig, so you've stored all the data into this object store. You then want to actually do reorganization of that data, extract the data and reorganize it, so you can do that. And then of course your analytic jobs, you know, your MapReduce, your standard MapReduce, or Hive. I'm sure you guys know Hadoop relatively well, but Hive is effectively a kind of structured database layer kind of view on top of your standard kind of objects underneath. So all of this to the applications is seamless because the API set is still HDFS. It looks exactly like an HDFS interface. It doesn't look any different. Now, the challenges with this has really been, so there's a couple of things you get as gains, and then I'll touch on some of the enhancements. So one, you get peer-to-peer storage system. You've got this availability gain, that every one of our nodes, if a node fails, I can add nodes on the fly, but if a node fails, I can redistribute the content on that node, or I can add another node into the system. So true peer-to-peer. There isn't a name node challenge. The second is locality. And locality has been one of the things that's held S3 storage back from being used for Hadoop. If you take the Amazon case, Amazon has hundreds of thousands of nodes all running S3. The problem is when I take a data source, if I'm running a Hadoop stuff and I'm pushing it into the object store and I'm just making an S3 call interface, it can go to any one of those nodes. And most likely it'll go remote. So what we can actually do is enforce locality. So we can actually you can actually use the data center tag key that we have to actually force that that you could have a Hadoop cluster that's actually running locally within this data center, and it's going to access only those few sets of private nodes. Or you could have another one running over in another data center running on the Hadoop set. So what you get is much better affinity of data and data access to Hadoop. And if you think about what Hadoop is trying to do, you've got to have close proximity of the data to the processing. That's one of the cores of Hadoop. Efficiency, you can store it with erasure coding, so it really depends on how you want to store that data. And remember, if you're actually going to go and pull data back into Hadoop and actually run analytics, it's actually okay to store it with erasure coding. It'll be a more capacity efficient way of storing it, and you can still run it on analytics. You will have a trade-off though, of course, on latency, so it's something you need to balance. And in these Hadoop instances, many times we see people actually deploy it as replicas versus erasure coding. But it's a choice the customers have. To the end user Hadoop application, you wouldn't notice. And then you can scale the cluster on demand, and as I mentioned, multi-part uploading. We actually saw about a factor of 5 improvement in performance by using multi-part uploading to actually upload bulk objects through HDFS versus just standard uploads. And rich metadata. So pig is effectively a transformer. Pig is a way to reorganize data, right? So it's an ETL tool to kind of reorganize data so that you're then going to run analysis on it. And oftentimes what it's doing is pulling back data, and we've got a lot of metadata on the object already. So you can actually filter based on that metadata to actually pull back select sets straight into pig. So pig doesn't have to pull back all the bulk set of the data and then run analytics. You can actually go and already have it filtered from our system. So a couple of cool things that we add. One of the big things as well is why this really works is you've got generally a smaller set of nodes. You've got data center affinity that you can actually manage, and that way you can kind of co-locate as much as possible processing with Hadoop and the data processing, which is really key. Use cases I won't go through. Clickstream, sentiment data, server log data. Let me show you what we do with smart support. So I believe strongly in eat your own dog food. You've got to kind of go and prove it and prove that it can work well. So what we've added into our system is smart support. We collect log telemetrics off the system here. We feed them over into a Cloudian hyperstore instance. So this is basically a multi-node. It's actually multi-node, multi-region deployment of our software. You then see the S3N bucket. That's the native bucket format that's actually going to be used within Hadoop to access it. So this is a Hortonworks cluster. Actually, that cluster is not a separate cluster. It's actually running on these data nodes. But that Hadoop cluster is then accessing via S3 buckets.
I'm sorry, did you say the Hortonworks cluster is actually running on the...
It's running on our data nodes. Our data nodes are basically standard Linux. They're standard Linux nodes. So effectively, you can choose whether you want to actually run, remote clusters, and really that's going to be down to how the customer wants to deploy things. Oftentimes, they will have more Hadoop nodes for processing nodes than they do data nodes. So then they will actually go separate. They may have 7 or 8 processing nodes and actually only need 3 data nodes. It really depends on the use case for the customer. So it depends on how it's set up. And then we run smart support analytics. So let me show you a quick kind of overview of how that kind of works. So, Philip, do you want to run through this one?
Sure. So we have our logs and data on our server, and it's going to be sent to the Cloudian Hadoop cluster for processing. And after, Hive queries will be ran against the data, and then this nice graph here will be displayed, and then sent back to an S3 bucket so we can share it within our organization, the results. And we use Ambari to set up our Hadoop environment. No load is going on right now, as we can see here. And it's a 4-node cluster, 4 node managers, 4 data nodes. So now my example program is being ran. All the data is being processed into Hive. All the SQL queries are being ran. And then it's going to output all of that data into a CSV format, which then will be graphed by GNU plot. And here you can see the map reduce jobs are running. The graph has been uploaded to the bucket with the S3 connector. And the next thing would be to...
Could you speak up a little, please?
The last step would be to use a client to view the bucket and examine the graph. And that's what we're doing right now. And this is our analytics data from our server logs. And that concludes our Hadoop demonstration. Thank you.
So I think you get a kind of quick sense, but where we see the possibility, first for our customers, the opportunity to actually run analytics in place on the data, because moving data, as we all know, is the costly thing to do. And you really want to avoid movement as much as possible. So this allows you to run analytics in place with the data. You get locality because we can do the data center conformance, and that way we can manage it. In terms of our use of it and smart support, you saw just a touch of it. In our next release, we're actually doing a whole new portal interface for our customers. So they will get a portal interface that will actually show them current state of their clusters, and we'll actually show them some of these analytic kind of rules that basically are showing trend rates for their systems and how the performance is going on their systems. So we're not going to get to a time in terms of it today to go through our roadmap. But what I would like to do is kind of open it up just kind of for questions. We've gone through a lot today, an awful lot. And I would love to kind of get your feedback on any areas of open questions that you still have in the last few minutes that we have. So in quick summary, the capability that we're really building, Mike touched on it at the very beginning, this smart data storage. Where we want to move data storage is, of course, we can build a highly scalable distributed store that can deal with bulk data very efficiently. It's got erasure coding built into it. It's got replication built into it. It's policy based so that you can get multi-tenanted and you can control on each tenant how you manage the policies on that data and how you want to store that data. It's got chargeback and quality of service built into it. The piece that I think is the more interesting piece is how do we now make those data systems much smarter? And you saw what we're doing here with Hadoop in terms of in-place analytics. You know that you saw even in the Hadoop stuff, we were actually using some of our tags to be able to pull back select subsets of data. So we can manage data much more fine-grained because we actually have metadata about the data.
Can you tell us kind of how many counters or something like that you're extracting from a cluster node per day or per minute?
Oh, God. How many counters do we extract from a cluster node per day?
How much data are you getting from?
I believe, the last thing I checked was, I think we're taking about 10 megabytes a day off each node is
of statistical information.
Of statistical information that we're pulling. I know that it's 10 meg a day, and that's in the current release. Actually, in the next release, we're expecting to massively increase.
To double. So, yeah.
I mean, just to give you a flavor, right. CPU utilization, network utilization, throughput utilization, S3 metrics, user metrics, so I mean, again, all the sensors, I'm drilling it in because the more data I can extract, the more correlation I can do. And I think, as we mentioned, it is not just for us; it's also for our customers because, my ideal support scenario is they should be calling me, I should be calling them. Hey, we found something. We already have working on hot fix. It's available. Why don't we deploy? That kind of a model, right? So go from reactive mode to proactive mode.
So I'm not sure if you heard any of that, but I think the key thing is we're moving the statistics from 10 megabyte to 20 megabyte in terms of per node stats that we're going to be pulling back into our systems. And our goal for this is how do we actually go and automatically analyze customer systems and come back with responses to the customer, automatically detect problems, situations before the customers even experience them. So with that, I'd like to thank you for your time here today, and really appreciate it. And thank you, Stephen, for setting this up. And if you have any questions, we can catch up later. For everybody online, if you go to Cloudian Storage is our Twitter handle. You can also go to cloudian.com and get access to a lot of data reports, our data sheets, a lot of deep white papers are also there, and we'll post them through Stephen's site as well. Okay.